Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Prahalad Murali, who holds a Ph.D. in Material Science and Engineering from Georgia Tech. So, how are you doing today?
Hey Rohan, thanks for having me on this podcast. Really great to be here, and I'm doing great. How about you?
Yeah, I'm also doing good. Thanks for being a guest. So, getting started, can I ask you what your experience was like when you were getting your education?
Just to give you a brief background, so I hold a bachelor's in technology in metallurgical and materials engineering from back in India, from National Institute of Technology, Trichy, and then I had come to the US initially to pursue a master's in material science and engineering, but then switched to a PhD midway. So that's how I ended up getting a PhD in material science from Georgia Tech. But now coming to your question as to my experience, so back when I was in undergrad, I was just trying out various different fields. Initially, I was more inclined towards pursuing management as a career path after engineering. But then, as I undertook a couple of internships in management, more on the marketing side, I didn't feel as much as a pull towards it. And then that pivoted me into pursuing a master's in material science. I had a brief summer research internship back at IIT Madras, wherein I worked on some thin films for semiconductor applications as part of my undergraduate internship. And that really helped me, propel to get my admits here in the US. So when I was still scouting for some research opportunities here in Georgia Tech, uh, I really was more inclined to work on semiconductor related applications, and I was pretty clear that I didn't want to go into academia for a full time job. I wanted to be closely associated with industry, and that eventually led me into taking up semiconductor packaging. As one of my PhD thesis was on a topic related to semiconductor packaging. So that's how I ended up here.
Um, while you're at Georgia Tech, can you talk a little more specifically about what your research was about?
Sure. So my research was more on magnetic core inductors. I gave a perspective on or trying to come up with better materials for the magnetic core, which are usually made up of magnetic materials, more like metal alloy or a composite. And my work was on trying to characterize these materials to improve power delivery of your data centers and server for and more targeted towards data center and server based applications, because the current requirements or the power requirements are increasing year over year, because just the compute that is required is also the demand for compute is also growing multifold, and it's unprecedented, especially after the advent of ChatGPT uh, and so on. So that my work was primarily on that, but also trying to come up with various integration schemes, trying to place these inductors in the various parts of an electronic package. So that's essentially what my thesis encompassed of.
How would you say your PhD has helped you as you moved on to careers, besides just
Oh,
looking good on a resume?
Oh, I mean, so PhD is something that you don't do just for the sake of beefing up your resume. It should be more because you want to learn the research methods, and then I think that's the primary motive. That's what I would look at. And I was very fortunate to work in a lab that had multiple industry collaborations. I used to, I used to work with the Semiconductor Research Corporation on one of their projects, and I had the chance to meet some of the industry members from Intel on semiconductors, applied materials, to name a few. So working with these folks really helped me to understand the broader vision of where my research fit into that. And where I worked at the Packaging Research Center at Georgia Tech, it was one of the few research centers in the world that focus on packaging as a research, because it's morely perceived as something that only the industry pursues. So you get first-hand knowledge as to what people are looking out for, especially from an industry perspective, because of the industry consortium and so on. And we used to have regular feedback cycles from the industry to help shape up a work that is more attractive to them as well. So doing those things, it really helps to get a flavor of both the academic side of things and the industry side of things. So, and that really helped me into getting a summer internship at Advanced Micro Devices here in Austin. And that's where I'm currently back full time. So I'm at AMD since January this year, and my work here at AMD is similar to what I've done back in my PhD as well. So it really helped me, the PhD really helped me set up the job as well.
Yeah. So what jobs have you held in between them then?
Sorry, can you come again?
Or what jobs have you held in between your? Oh wait, no, you did go straight there. But yeah. Wait, can you talk about what your days look like at AMD?
Yeah, so each day is going to be different, but on the overall, if you look at a month, what we try to do is advance towards the next technology block. So we work with at least my team. I'm in the advanced technology team in the packaging organization. So my work is more on the integration, meaning we have to work with various folks on the silicon design engineering, and then our external suppliers, and also some internal package design teams. So what we do is we have to come up with a new technology, and these technology cannot directly translate into products without any validation or tests, right? So we start off with some simulation or modeling that will help us give direction towards where we want to be, and we try to run some test vehicles to validate the technology and see what can be made better, and then we try to intercept with a product. So we already have a product intercept in mind, but we want to validate these technologies so as to be, there's no issues when we are trying to integrate a new technology block. And whenever you're trying to come up with new technology blocks, it's usually disruptive to the current existing chain of things. So you would need to ensure that everything flows smoothly without any hiccups that you might want to anticipate.
What parts do you work on?
So I'm more on the server and data center GPU. That's where I am slowly focused on. Yeah.
Oh, I was about to ask how AI affected you, but that means it affected you like very massively then, right?
Um, Actually, I wouldn't say it would. So AI, the way I see it, it's not going to affect, you know, or at least in a broader sense, packaging engineers like us, wherein we are working on new technologies, and we are essentially trying to invent a new technology block. Um, so it would definitely help me assist in some of the day-to-day tasks that I do, but which would definitely help increase productivity. But I would still say that is a few years down the line. Right now, I've seen a lot of interest in using AI or ChatGPT in trying to, write lines of code. So instead of, let's say, 10 engineers, we can, work with three proficient engineers, and they can help debug the code that ChatGPT helps. But I'm trying to have a widespread adoption of this. I think it would still take some more time for this to percolate towards the masses.
Or ChatGPT caused like a much larger demand though for these data centers.
Oh yes, definitely. The demands. there's been an inflection point, right, somewhere around in 2022 is when ChatGPT was introduced to the world, and with every iteration of ChatGPT and Google coming up with its own AI feature, Amazon has something, and you have to also understand that there are some AI tools which are proprietary to the company, which they will use on in their internal workflows. Combining all of this, then you get a sudden boom or a sudden increase in compute. But you also need to ensure that your energy demands, are needed. So some of these data centers take up to a few, tens of megawatts. And recently, I saw an article that they're planning to build a 200 to 300 megawatt data center here in Texas. So yeah, I mean, as you can see, as the power levels go up, that means you need more and more, compute power, and that would mean more and more demand from our teams. Yeah.
Wait, can you put into perspective how much power that is?
Um, yeah, as I mentioned to you, like it's the package or how much your each a few set of chiplets or what we call chips take is inching towards close to a 1 kilowatt, and that is only expected to grow. So we can expect in the next 2 or 3 years, we should expect a 1 kilowatt package. And when you come at the rack level, so you at the rack level you have multiple of these packages which communicate with each other, but also between racks. And each rack would probably be like 4 or 5 kilowatts. So and just imagine that through an entire stack of racks which are vertically stacked, and besides that you'll have multiple racks even laterally spaced as well. So putting these together, I think we are looking at about tens of megawatts for a decently sized data center.
Yeah. For your job, do you ever get to actually go in person to these data centers?
No, we don't. I don't indirectly interface with our end customers. I work more on the back end chain of things, wherein we try to put together all of these packages. We get feedback from the front end teams as to how or what the competition is looking at, and also what should be our focus. So it's like a feedback cycle, and yeah. But yeah, to answer to your question, I don't directly work with our end customers.
Um, so earlier when you're saying how like obviously ChatGPT makes it much easier to code and do some of like that busy work. For someone like you who's like physically designing things and packaging things, uh, so were you saying a few years from now you think you'll also be able to start helping with those?
Well, yeah, to some level, right? People confuse automation with AI. So there are already some automation tools which are available, even for the general public, on some of your softwares. So AI, the way I see it, it takes up data from previous data points and then tries to predict, okay, this is where we have to look at, or at least gives you a perspective, right, with some kind of confidence or certainty. Um, but yeah, like it would definitely help us. Let's say, take for an example, right? We're designing, something, and you have to place your capacitors, or let's say your inductors or resistors. So how do you place them in a most efficient manner that you should ensure that it not only meets the electrical requirements, but also any kind of thermal barriers that might be there or thermal requirements, and they should also be yielding, meaning when I'm trying to manufacture those parts, I should have a really good yield. If I'm going to take a hit on my yield, then I'm essentially losing out on margins, right? So that's the cost associated with it. So it would be interesting to see, kind of what the bounding box of to these AI related tools would be, and yeah, with every iteration on that, we can eventually make it more compelling to assist in our day-to-day uses. But yeah, that's the way I see it.
Um, Next, I wanted to ask you what advice you'd have for someone wanting to go in a similar field as you, who's still in high school or very early in college.
So, to be honest, back when I was looking for colleges here in the US, I did my undergrad between 2015 and 2019. So, 4 years of undergrad, and I knew what chip making was and so on, but we were never taught about semiconductor packaging. But now, as you might have all heard, Moore's law is slowing down, Moore's law is coming to an end. Uh, so, packaging has now been in the forefront, if and probably it's now more important than ever it was before. So back then, packaging was more of an afterthought, but right now people are looking at packaging as a really key enabler to help give the compute demands. So since I didn't have any background, it was all new to me. Like I would, well, to a layman, packaging would be the Amazon boxes or something that you would get your products in, right? So this is more, of course, going to be more complex than that, but it's essentially trying to place your chips onto the same substrate or material, so as to enable a good communication between each of the chips and between the chips and to the external world. So that's what packaging is, and uh, to someone to get into packaging, you don't end up. I mean, eventually people just it just so happens to end up in packaging, but I guess to answer to your question, it'd be nice to have more interdisciplinary engineers, someone who brings to the table electrical, material science, probably even mechanical, all of these put together. So if you're in college, if someone's looking to get into college, I would definitely ask you to look beyond just computer science. It's still hot right now with all the AI and everything, but remember, software is only as good as your hardware. So if your hardware is not able to enable that, your software I mean, it's essentially hardware limited at the end of the day, right? So you would have to look into working in hardware. Like the work is pretty interesting as you work in a 3 or 4 year down the line products, especially in companies like AMD. And the idea would be to get a more interdisciplinary coursework if your university allows you to, and work on some internships and work with some professors as you're going by, and that would definitely help you give you diverse perspectives and to see what works best for you.
Can you talk a little bit about what exactly material science is?
So, material science, to put it simply, it's essentially studying the properties of any kind of material. Like for example, for let's say I'm working in packaging, and we have dielectrics in the substrate. So we would have to ensure that these dielectrics are electrically insulating to a level that we would like it to be. They should be low loss, because when you're transmitting these signals at really high speeds in the gigahertz frequency, they should be low loss, so you don't spend up more power, because then you're burning power in just trying to transmit these signals between your chips. Uh, so just to give you an example, and let's say you are working in a company like some kind of a steel company, then you would need to ensure that you study the properties of materials, or the metals, or the kind of input oxides or the ores that you put in, to ensure that you get the right product at the end of the day. So it's essentially just studying the properties of materials and tweaking those properties, by maybe adding some external dopants or impurities. Usually, that's what happens in the semiconductor wafers at the wafer level. So that would really, it's essentially a study of materials, to put it simply. Yeah.
But yeah, I've talked to people who both majored in electrical engineering and you who's majored in material science and have also gone into packaging. I
Sorry,
know.
I didn't get your first half of the question.
Or I've talked to people who work in packaging who've worked
Yes.
in obviously you with material science and people who've majored in electrical engineering.
Mhm. And there are
So,
people who with mechanical engineering backgrounds as well. So when you're talking to a team of people in packaging, you can definitely see an electrical engineer, a material science engineer, and there are people who have, even also moved from computer engineering, wherein they look at computer architectures, and I've seen a couple of people like that. So essentially, packaging is for everybody. If we don't really, kind of discriminate, so as to say. But it's more like you have to talk to other people, try to understand, what their job is. So it's not very monotonous, right? So you each day is going to be a different learning.
Yeah. And you were saying Georgia Tech was one of the only schools to have like a specific packaging lab, or was it
One of the few schools. So in the US, right now in UCLA has the CHIPS lab, and then Penn State is coming up with its own packaging, right? Right. So with especially the CHIPS Act and a lot of money being pumped into packaging, we can see a lot of new packaging centers coming up. There's also this Texas Institute for Electronics, which is um, based out of, if I'm not wrong, UT Austin, and it's like a consortium with a lot of other universities. Wherein there'll be multidisciplinary research taking place.
do you think wait, so you were able to take a lot of classes in between electrical materials and mechanical, right?
So I was not able to do classes in mechanical because there were not many courses that suited my interest with respect to packaging. But yes, between material science and electrical, I would say, yeah, it would be like 30% electrical and 70% material science. But even the 30% electrical, it was more like an interdisciplinary course between material science and electrical. It was cross-listed. So that way, material science engineers could get a flavor of the electrical engineering as well.
And did you also do electrical engineering courses during your PhD?
Not any core electrical engineering courses, but it was more tailored towards semiconductor process, process control, and then optoelectronics. So, but midway, you still have to learn some electrical engineering concepts to
Yeah,
understand
if you're working
the
in
material.
the packaging lab, right?
Yep, yep.
Yeah. But yeah, yeah, right now I'm also pretty interested in electrical engineering. And you're saying, uh, if you had to like say like what the biggest topics are, I guess within electrical engineering, where would you place packaging like right now?
And I would say packaging should be definitely in the top three. Besides just your power distribution, like your power networks or your grids, right? Because the power demands, are just going to increase, and I guess besides the EV and power electronics kind of applications, I would definitely put packaging to be in the top three. Yeah.
Were you ever interested in any other uh things within, I guess, material science aside from packaging?
Um, I was kind of interested in batteries related research and a short stint in my undergrad when I worked for my final year project. It was more on the biomaterials. But for some reason, I mean, sometimes you just don't have a reason as to why you're not interested. It's just not interesting to me.
Yeah.
But I do understand the kind of importance battery materials have, energy storage materials, and so on. But for me, packaging was a very I don't know. It just kept me interesting and still does after, I guess, it's been close to, I joined my lab in 2020 January. So still more than 4.5 years, I'm still interested in packaging.
Yeah. Do you see yourself continuing packaging for the rest of your career?
At least for the foreseeable future, I would definitely want to be associated with packaging in one way or the other, either be it in engineering or, more like advanced technology tools that I'm currently working on. This because there's still a lot to learn. Like even at the school level, I mean, there's still that disconnect, right? Because not all the thing you'll not know all the things when you're in the school because of the how proprietary some of the information is at the industry level. So in order for you to know more about how the industry works and you know for you to shift gears between the school mode and work mode. I think hardware industry is not something where you can just keep switching every year, because then you would not have a lot of learning. So I would definitely, for the foreseeable future, I would definitely see myself in packaging.
Yeah. All right then. Thanks for meeting with me.
Of course, it was great to talk to you, Rohan. It was a very interesting conversation, and yeah, hope you have a great rest of your day.
Thank you.